Hello, welcome back to another lecture. In this lecture, we do want to try to have an I-beam here with the different size of flange and web. And what we like to do here to find the section modules of SX and ZX, the plastic module, and also find the shape factor. The first thing we're going to do, we're going to go after SX. To find SX, first we have to find the neutral axis of this shape. After we find the neutral axis, we can calculate the moment inertia, and after we calculate the moment inertia, we can go ahead and proceed from there. So let's go ahead and find the neutral axis, and we've assumed that, say, the neutral axis is someplace around here. Okay, let's call that neutral axis. All right, and what we're going to do here, well, we're going to say, okay, let's find the centroid of this shape, neutral axis, and y bar is equal summation of y bar times area divided by summation of all area. And let's make down here, say this is area number 1, and this will be number 2, and let's make this shape number 3. So we got 3 different shapes here. Okay, top flange, the web, bottom flange. And then we're going to go ahead and calculate this. So my y bar is I'm going to use a little bit of room here. Y bar, come over here, be easier. Y bar is equal shape 1. And when we do a shape 1, let's use it as a reference point and go right here. Say this is our reference point, X. We're going to measure everything from here up, from this line, which we call X right there. So shape 1 is going to be the y bar. And this is 2 inches. Okay, so 2 inch, the center of this is going to be 1. So, and it's going to be 1. And if from here all the way to bottom here is 28 inches, therefore, the center of here is 27 inches to the bottom. So my y bar is 27 inches. 27 multiplied by the area of 1, okay? So area of 1 is 2 times 8, correct? This is the area of 1, and it's 2 inches by 8. And then divide that by the area bottom, which is 2 times 8. Plus, let's keep going. Now we're going to go to area number 2. Okay, the center of the area number 2 is 28. From here to here is 24 inches. So 24 inches divided by 2, the center of this, just the shape, just the web, never mind anything else. The center of the web is going to be 12 inches, right? If it's 24 from here to here, then therefore center of this triangle right here, the web, the center is going to be 12 inch. So that's 12 inch from here. So that means 12 inch from here, so it's going to be 12 and 2 is 14. So my y bar is equal 14. Multiplied by area of the web, which is 0.5, half inch, and multiplied by 24. And the area is 0.5 times 24 plus. We got one more shape to go. Hang it in there. Shape number 3 is right here. Okay, the center of this shape is right here, is 1. And it's 1 from the x-axis, so it's 1. So my y bar is 1. Wonderful. Multiplied by the area of this shape number 3, which is 2 by 12. The area is 2 by 12. And that comes out to, I already have calculated, it should come out to 12 inches. Okay. Okay, so now we have 12 inches. That means the distance from here to my neutral axis is 12 inches. Okay, now we found the neutral axis location. The next thing we're going to go ahead, we're going to calculate the moment inertia for that shape. So the moment inertia, remember that in the kindergarten? Oh, sure you remember. 112b h cubed plus ad squared. We got to do this for all 3 different shapes. Okay, B, this is your width of B, or that's your B. Your H is the height of each individual shape. That's good. A is the area of each individual shape. Beautiful. D is the distance. Okay, pay attention now. D is the distance between center line, the center of your shape, and the neutral axis. That's what we're going to do. All right, let's go to work here. So we're going to equal 1 divided by 12. Let's start out with shape number 1 on top. And that's B is what? 8 inches. I got it. H is only 2 inches. Okay, 2 by power 3. Plus area, H is 8 by 2. D. Now the D is the center of this shape is here, is 1 inch from the top. So 1 inch from the top, one thing we should have done is if this is 12 to here, then from here to top, also it's good idea to say what distance this comes in. So that's going to be 28 minus 12. Yes, 28, it'd be 16 inches. So this is 16 inches from the top. Okay, we're cooking now. So we're going to say, okay, if that's from here, so that's going to be 15 inches. To multiply by 15, my D is going to be 15. Don't forget that's an AD square, because I made that mistake. So that's a shape 1. Let's go to plus shape 2. Shape 2 is the web itself, okay? And the area of the web, well, 112. This is 112. B is 0.5, half an inch. H is 24 inch cube. Then we have plus AD squared plus A. Yes, 0.5 times 24, and my D. Okay, center of my shape is D right here. It's 24 divided by 12, so it's 12 inch from here. 12 inch from here, or 14 inch from here, right? So if it's 12 inch, center of this shape, don't confuse yourself here. Different color here. No. Yeah, green is good. Center of this shape here is right here. And the center of this shape is 14 inch from the bottom. But neutral axis is 12 inch from the bottom. Because from here to here is 24 inch. My center is 12 inch. So 12 inch from, that's the center of here. But that 12 inch, if I measure this to the center of here, is 14 inch from the bottom. So the difference between that and neutral axis is 2. Okay, that's shape number 2. Then plus, let's go shape number 3, which is 112. My B is 12 inches. My H is 2 by power 3, plus A is 12 times 2. And D. D is the distance from the center of this shape to the neutral axis. And that will be 11, right? Because if this is 2 inches, so I'm here 1 inch up, and then I go, there'll be 11. 11 squared, and this should be squared, by the way. So that comes out to, I have calculated that to become 714. 1.33 inch by power 4. Perfect. Now we have calculated the moment inertia. We remember the stress is equal mc over I, or same as a my divided by I, or same as m divided by s. Or we had also the equation was we said also S is equal I divided by C. Now remember, we're going to have two of these. Which C you're going to use? Is you going to use this one, or you're going to use this one? Okay, so we're going to use the smallest one. That's one to control. So I have my I, all right? My I came out to 714.1.3, and I can divide that by 16, because we want to go, C is the maximum distance. The maximum distance from neutral axis will be 16. So that's one we're going to control. So it's going to be divided by 16.
I should have done this, but I think I have. That is 714.1.3 divided by 16 and 446.3.
Okay, 446.3. That's my SX, and that's one answer. Okay, now we got this. That was easy. Okay, to next step, we want to find Z, to plastic moment. That's a little bit more complicated. So, tell you what, I give you, give me a couple of seconds, I can erase all this stuff up. The plastic neutral axis is a little bit more complicated. It's not as easy as that one. And let's go over some stuff first. Remember in kindergarten or in statics, mechanic material 2, that we learned, take a look at the curve, what I'm putting on the board here. Let me put on the board here. So take a look at that. When we had the elastic behavior and we had the yield stress. So I need room, but I'm going to make this quick. So we had going up to here, and we said, okay, this is the Fy here. So this was the elastic range. But what happened when it went up a little bit here and went up down, and it came back down here, and finally the steel cracked here when we put a tension on it. So now beyond this range is a plastic, because you stretch the steel. So when a plastic zone, that's a different story. Excuse me. So if I just go ahead and make a quick thing here. And here, when we're in elastic zone, so this is my I right here, I beam, and coming in my neutral axis, and we had this line here, and we had something like the stress distribution was like that. That's fine, okay, which was less than Fy, you know, and bottom and top, or because we want to stay in a linear or we want to stay in an elastic zone, and that's how we design things. But when we go beyond that, we become plastic zone. In plastic zone is a little bit different. So if we have this here, and again, let's put a web right into it a little bit. Don't pick up my drawing, it's a very nice drawing actually. Then we have the neutral axis. What happened is everything is going to be like this. The forces on top is the forces on equal the forces on bottom. So the tension and compression on top become equal. And this is a F. This will be F what? This will be F of top flange. It will be basically the area time Fy, but the area will be a top flange for a top flange, and then this will be the area of the web portion, and the web portion time Fy, and then same thing down bottom. These two are equal forces. So this is how we're going to take advantage of that to find the limit. All right, let me erase that, and we can come up with the formula for it, how we arrive at it.
Very good. Okay. Okay, we'll write that down here. All right, so we're going to say, because this is a plastic, the forces on top is equal to forces on bottom. Tension is equal compression.
So I'm going to say, all right, let's make room for myself a little bit. Okay, I have wrote down force of compression equal force of tension, and the bottom and top. And now look at these, how we have this here. Basically, I want to say A1. I mean A1, which is the area of this right here. Let's call this 1 for now. This would be 1. But I want to confuse because we're going to use that number again. So this area, A of flange top time Fy, okay, that's the compression, the tension on top. Then from here, I'm looking for this area right here. So now I know I got this A1, and I'm going to look for this area of this web, just this section. So that's going to be the area of the web of top part times Fy. And that should equal the area of the bottom flange, area of bottom flange, okay, BF or FB, and then time Fy, and that's equal plus, sorry. Now we have the web force, and that's going to be the area of the bottom web time Fy. Easier said than done. Now let's
write these out. Okay, if we write these down, and it's going to become because I need a lot of room, so I'm going to start from here.
So area of flange, top flange.
So the area of top flange is equal. That is equal.
The area of top flange, it's going to become TF1 multiplied by B1. Okay, that's the area, and multiplied by Fy. Plus, right?
And
now the web is going to be a hard time to figure out, okay? The area of this web here, okay, which is TW, we got that part, that was easy, okay? Now TW multiplied by, what is the length? I don't know the length, but I know if this is from here to here is my plastic neutral axis YP, that's going to be YP minus TF. So this distance is going to be YP minus TF time YP minus TF. Wonderful. So that time that, so now we got the forces on this right, and time Fy, don't forget that, and that's equal to the bottom part. The tension and compression, they equal here. So the bottom part, let's figure out the area of this here. Ugh. And the only thing we know about this is TW. All right, that's the area. But what's the length of here? I know that this is YP from here to now here. This is a little bit complicated. We've got to find the area of this portion here, this right here, this area. Okay, this the bottom web. The area bottom web, we know TW part. That's the easy part of it. Okay, so how do I get to find out this area? Well, I know right here I got H. This from here to here is H. So I say H, okay, minus, let's take out the thickness of both flanges. So now I have this distance just left over, right? So minus top flange TF1 minus TF2, okay? So now I have this. So I got this distance finally figured out here, but I'm looking for this. That's not going to help me. So to get this, I'm going to have minus, okay? So now I have this, so I got to take this out. And this distance is what? This distance we already calculated, we said it was YP minus TF, right? If this is YP, that's TF1. So time minus YP minus TF1. That's a nice looking TF. I ever wrote one, huh? TF1. Okay, we good. And then we close this out. So that's the web. And the other one is easy, which is these here. The area of this is going to be B2 plus B2 time TF2 and time time Fy. Excuse me. Okay, now we got this figured out, okay? This is simple. We can simplify this a little bit. We can cut all the Fy out, okay, because on both sides. And then we can calculate for Yp. To calculate for Yp, I'm going to come back up here. All right, let's use a different color. Okay. And that's going to be, we figure out for Yp, and Yp is equal, I want to go blue. I don't like this color. Yp is equal, so we have TF1, Yp is equal, okay, I got TF1,
and then I have time B1, then
minus TF1 times TW minus TW time H
and plus
TW
time TF2 minus TF2 time
B2
and divide the whole thing by TW. So everything is in this format, so pretty easy to follow this right here.
And if I put the number into it, let's put the number into it. So YP comes out to
TF time B1.
that's I forgot something here.
It should be
This whole thing should be, let's say YP is equal 0.5 multiplied by the whole thing. Okay, 0.5.
all right.
So I got here is equal 0.5 multiplied by,
And then I have
TF times B1. All right, what is my TF? TF is 2 inches. Okay, 2 inches times B1. B1 is 8 inches. Okay, and then minus, then I have TF1 times W. TF1 times TW. So that is 2 times TW is what, half an inch, multiplied by 0.5. And then I have minus TW, which is again, T web is half an inch, multiplied by H. The whole H was 28 inches. Okay. And then I have plus TW 0.5 times TF2, which is 2 inch, and minus TF2, which is 2 times B2, which is 12. 2 times 12. Did I miss anything? Let me see what I got. 2 by 8 minus 2 times 1/2 minus half times 28 plus 1/2 times 2 minus 2 times 12 divided by 0.5. Divide the whole thing by 0.5, and YP, it comes out to 22 inches. Okay. So now my plastic range is going to come out to, I'm going to go ahead and erase this, and I'm just going to go to the plastic zone here. Okay, so now I go ahead and I redid this over again and put in the plastic neutral axis. I got rid of the neutral axis because I need room for here. So neutral axis is going to be 6 inches from the bottom or 20 inches from the top. I mean plastic neutral axis. And then now we're going to go ahead and calculate Z. Remember, you got 4 different areas. You got area 1, you got area 2, and this is area 3 and 4. And let's make that to a 4 right here. Okay. Actually, yeah, let's just call it 4 for now because you got the bottom and the top. The tension, compression are equal, so you got to count it for the forces on this flange and a web right here, and a flange on top, and a web on top. All right, so the Z calculation kind of comes out to Z is equal, it's going to be A times Y1, that's a A1, plus A2 times Y2, plus A3 times Y3, plus A4 times, how about Y4? All right. And let's do that. And okay, A1 is 8 times 12, right? So I got 8 times 12
then plus, wait a minute, time, that's a time, what would have happened to the y? Okay, y1. y1 is 21 inches. How do I got 21 inches? Let's look at y1, okay? y1 is the difference between center of this shape and the plastic neutral axis. If it's from here to here is 22, then from center is, which is about 1 inch below it, it's 21. All right, that is that, plus A2. A2 is this area right here. And this area happened to be ½ inch. I got that part. That's the easy part. ½ inch. What's the length of that area? It's going to be... So, again, let's explain this one more time. This is a 20 inches. How do I get 20 inches? If it's from here to here is 24, right? So from here to here is 26. But I am looking for just from here to here. So 26, right? If I say 26 minus 6, that will give me 20. So that's 20. So I got 0.5 or times 20. That's the area of here. And then multiply by the centroid of this. And if this is a 20, so this is a 20 right here. So this right here, from here, we figured out to be 20 inches. So if that's 20, the center is going to be 10. So 10 is going to be center of here. What's the difference between the center and here? It's going to be 5. It's going to be right here. It's a 10. It's going to be 10. So it's going to be 10. All right, multiply by 10. Then plus we have this area number 4. Let's do the area number 4. No, just do area number 3. The area number 3 is 12 times 2. We know that 12 times 2, and then the center of this is that is 5. That was easy. And plus, I have this one here, which is a 0.5. Multiply that by this length right here. Well, if it's from here to here is 6 inches, and take 6 out, it will be what? It will be 4, right? So that's going to become 4. And then multiply that by the center of this is going to be from here, which is if this is a 4, it's going to be 2, right? Times 2. And if you calculate all these numbers, it should come out to 560. 560 inch by power 3. That's your Z. Okay, now we found Z. We're in good shape. Let's calculate the shape factor. Okay, the shape factor is, I need room. I'm going to go right here. Whoops. Shape. What was it? S? Oh, right here. Shape factors is equal. Okay, it's what do I wrote down here? Do I have the right number? All right, it's a Z divided by SX, and Z was 560, which is equal 560 divided by 446.3, and that comes out to oh yeah, I did it. Okay, it comes out to 1.25, and that's our answer. How we got it.